Welcome to ClickMyProject.com. Now we discuss about the product, a contrast adjustment thresholding method for surface defect detection based on Mesoscopy. Now we discuss the abstract for the process. Defects that are identified can be modified to satisfy predominant quality requirement, or in case of severe defects the coating would be rejected. Some methods were used to detect defects in coating in existing system. This project proposes two new thresholding methods. These are the contrast adjustment OSTO method. The OSTO method is nothing but the morphological method. They are the thresholding, and the contrast adjusted median OSTO method, and these are developed for the detection of defects on high resolution image of titanium coated aluminum species. Experimental results have shown that proposed contrast adjustment method have performance similar to minimum error thresholding, that is MET, and are generally better than OSTO method. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. The dataset is nothing but the folder which consists of the several images undergone for the process. After getting the input image from the dataset, the pre-processing is carried out. In the pre-processing, we have majorly considered the noise filtering. The noise filtering is nothing but the filtering the noise from the image. After the noise filtering, the noise-free image is converted into the grayscale. This step is known as the grayscale conversion. After the grayscale conversion, the OSTO method is applied. The OSTO method is applied by using the corresponding threshold value. After applying the OSTO method, the contrast adjustment OSTO and the median based contrast adjustment OSTO method is carried out. After carrying these two steps, the detect defects are carried out. In the detect defects method, the number of blobs which is affected is shown. After detecting the defect in the plate, the estimation is carried out. In the estimation step, we have calculated the number of detected region and the elapsed time, and the accuracy is calculated. Then these three estimations are plotted as an graph. Now we discuss the initial running procedure for the process. At first, you can see the number of files in the current folder. In that, you can see the main file. The first one is the main.figure file, and the second one is the main.m file. Now select the main.m file and right click in that file. You can see the third option, run. Now click the run. Now the initial GUI window was opened. In that, you can see the several edit boxes and the several buttons. These edit boxes are used to display the values, and these push buttons are used for the undergone for process. Now you can see the one folder icon. Click in the folder icon. Now the dataset folder is appears. Select an image from the dataset folder, then click the button view image. After clicking the button view image, the respected image is shown in the axis 1 with the title input image. Then click the button pre-processing. After clicking the button pre-processing, the pre-processed image, that is the filtered image, is shown in the axis 1 with the title filtered image. Then convert the filtered image into an grayscale image. So click the button gray conversion. After clicking the button gray conversion, the grayscale image is appear in the axis 1 with the title gray image. The corresponding length of the image, width of the image, and number of channel of the image, the maximum and the minimum pixels of the images are shown in the edit box. Now click the button OSTO method. Now the thresholding value for the gray level is shown in the edit box. Now the gray value is 0.38. After applying the Otsu method, now click the button Otsu method for contrast adjustment. The Otsu method contrast adjustment image is shown in the axis 1. Now the binary image is shown in the axis 1 with the title binary image. After finding the binary image, click the button median based Otsu contrast adjustment. Now the median based contrast adjustment method is shown in the axis 1. Now click the MAT. Now the image is arranged in a single array format. Then click the button percentage estimations. After estimating the percentage estimation, then click the button resultant image. The resultant image is shown in the axis 1 with the title resultant image. The corresponding threshold value also shown in the edit box, that is the 0.41. Then click the button estimations. The number of blobs detected by the estimation is equal to 8. Now click the button graphs. After clicking the button graphs, one new guide window was opened. In that you can see the three buttons. First one is the bar graph, then the second one is the line graph, and the third one is estimated values. Now I click the button bar graph. Now the bar graph for the existing and the proposed work is shown. The accuracy for existing and the proposed work is shown. The proposed first bar represent the accuracy of the proposed method, and the second bar represent the accuracy of the existing system. Then click the button line graph. After clicking the line graph, the accuracy values of the both proposed and existing are plotted as an line graph format. Then click the button estimated values. The estimated values are shown in the table 1 and the axis 2, axis 3 and axis 4. These are the correspondent time intervals taken for the each and every process. The time 1, time 2, time 3, time 4, time 5 values are plotted in the table as well as bar chart as well as in the line chart. Thank you.